Example of the filter. So let's see the question. Consider the full wave rectifier. So you have two types of full wave. The first one is what we call center tap. The second one is called full bridge. So in your center tap, you have how many diode? It will be set tap at the center, and then you have two diode here. And this one will be connected, and then you have what we call V out. So in this question, it says center tap rectifier. The capacitor is connected in parallel. So where will be the capacitor? It will be in parallel with your load here. This is your R. Okay. And the value is 2.5 kilo ohm. The input voltage has a peak value of 120. So the input voltage here means here the V secondary after the transformer. The peak value here is 120. So if we draw the graph, so this will be your Vs, the input voltage. The peak here is 120 with a frequency of 60 Hz. The output voltage cannot be lower than 100. Output voltage means the voltage at here, that is your VR, will be the same with the voltage at your capacitor, because this is parallel, cannot be lower than 100. So if we redraw the graph, so what will be happen at the output? So this is full wave rectifier. So how you can get your V out from this circuit? So if you have the equation of here will be plus minus, right? Means at this cycle, plus cycle, what will happen? This diode will be off, diode will be on. So your equation here is minus Vs plus your diode will be replaced with V gamma plus the voltage output there equal to 0. So you can get your V out equal Vs minus V gamma. So you're going to get a smaller voltage at your output here. Okay. So once it reaches the maximum voltage, so this means the capacitor will be charged. Means diode will be on, your capacitor will be charged. Okay, once your voltage start to decrease, that's where the diode will be off, right? So when the diode will be off, you will be slowly discharged. Until when? Until it reaches the second positive cycle, then it will be charged again. Okay, now so let's see the value given. Input is 120 volt, so this one is 120 volt. The output voltage, so the red one here is the output voltage, cannot be lower than 100. What does that mean? The minimum voltage that it start to discharge, the minimum one here cannot be lower than 100. So if we denote here, what will be the ripple voltage? So here is your ripple between this line, the peak from your output voltage until the voltage that is minimum here is 100. So we need to know what is the value of the voltage after the diode. Okay, so just now you can get the equation here. Your V out is equal Vs minus V gamma. So what is your Vs just now? The blue one is Vs, right? 2120 minus 0.7. So you can get, so we didn't denote here V out, we denote here Vm. So this should be Vm. So this is Vm equal 119.3 volt. So from here, you can get this Vm is 119.3. You already know Vm, you already know the minimum voltage here is 100. Can you get your ripple? So your ripple is actually 119.3 minus 100. Then you can get here 19.3 volt. So the formula for your ripple, the question says you need to find the value of your capacitance. So for full wave, your ripple voltage equal to FRC. So what will be your ripple voltage? 19.3. What is your Vm? Vm is the voltage after the diode. That is 119.3 divided by 260. R is 2.5K, and then C. Then you can get your capacitor value. So your capacitor value there is 20.6 microfarad. So in this equation, here we don't denote directly V out, we denote here VM, because this VM is the voltage after the diode, right, the maximum, and then when it start to discharge, this area will be what we call diode will be off, and the capacitor start to discharge and charge again, discharge and charge again. So the value between the maximum here and the minimum here we call ripple voltage. So how you're going to tackle this question? Take the keynote, center tap on the two diodes. Check this is P of Vs, so this is V secondary, and between here you can get your ripple voltage. Okay, so let's see the second question. The question just now is the center tap. So this question is called bridge rectifier. So when we say bridge, so means you have four diode, right? 1, 2, 3, and 4. So in order for this diode to turn on, you need to go through how many diodes? So let's say you're going to connect here to R. Okay, so in order for you to have the complete loop, you will go through, let's say this is diode 1, diode 2, and then the final one. So to complete one loop, you need to go through how many diode? You need to go through 2 diode. So if you derive the equation starting from here, it becomes minus Vs plus V gamma plus here is actually your V out plus again V gamma equal to 0. So you can get your V out is actually Vs. Not only 1 V gamma, it becomes 2 V gamma, because this is what we call full wave bridge rectifier. Okay. So the question given here C and R, and your input here from your secondary here is 50, the peak voltage here is 50 volt. Assume V gamma is 0.7, calculate the ripple voltage. So for your full wave rectifier, the formula is given here, Vm divided by 2 FRC. What is actually Vm? Vm is actually your voltage after your diode. Means this V out, the one that you derived the equation just now. So let's replace the equation. Yes, Vs minus 2 V gamma. Your Vs, you need to only take the peak, so become 2 multiplied by 1.4, then you can get your Vm. So sorry, just now this is not 1.4, your V gamma here is 0.7, so you can get here 50 minus 1.4. So you can get here 48.6 volt. So this is the voltage after the diode. So the question says you want the ripple voltage. So your Vm here is 48.6 divided by 2. F given here is 60 because 2 pi ft, right? Multiplied by your R is given here 10k, and your C is given here 20.3 microfarad. And then you can get your ripple voltage here is 2 volt. 2 volt for full wave rectifier. So these are 2 examples in the filter. So try to go through by yourself. So try to understand all the value given for your filter. So in that case, we close the topic of filter. We move to the voltage regulator in the next video. Assalamualaikum class.